Today we'll be studying imperfection in crystalline solids. Crystal contains defect because their particles are not arranged in orderly manner. It is of two types, point defect and line defect. Point defect is when the defect is at a point. For example, let us see if there's a crystal like this. If defect is at a point, it is known as point defect. If defect is along a row, it is known as line defect. Now, types of point defect. I hope you've understood. Point defect is at a particular point and line defect is at a particular row. Now, point defect is of three types. Stoichiometric defect, non-stoichiometric defect, and impurity defect. Today we'll be studying stoichiometric defect. Stoichiometric defect is when the constituent particles of solid are present in the same ratio as predicted by the formula. Or we can say when the molecular formula and the structural formula are the same, that is stoichiometric defect. And now, first of all, we'll study the defect in ionic solids, and that is Schottky defect. As the name indicates, Schottky means short. Short means some ions are leaving the crystal lattice. Some ions are leaving the crystal lattice. See, some ions have left the crystal lattice. Schottky. Schottky means short. Now, when there is short, naturally the density will decrease. Now, there are holes. What will happen? The conductivity will increase. There are holes. What will happen? The stability of crystal will decrease. Now, Schottky defect occurs where the ionic compounds have got high coordination number and their cation and anions are of similar size. For example, NaCl, KCl, cesium chloride, potassium bromide, AgBr. So again, let me repeat. Schottky defect is when the density will decrease, electric conductivity will increase, and the stability will decrease. Electrically it will be neutral because the number of cations and the number of anions are the same. They have not changed. Now, next defect is Frankel defect. In Frankel defect, it is usually the ion which leaves the crystal site. But the ion which leaves the crystal site is usually cation. Since the cation is smaller in size, it can leave easily and occupies the interstitial position. Interstitial position is this position. This position is interstitial position. In this also holes are created. See, this is interstitial position. In this also holes are created. And now here the ionic compounds are of, they have difference in size and they have low coordination number. And this defect is also known as dislocation defect because the ion has left its position and occupied some other site. Right? Here, see what will happen. The density will remain the same. The density will not change. Density will remain the same. Electrical conductivity will increase. Since here also the number of cations and the anions are the same, the electrical neutrality will remain the same. Now, let me tell you the Frankel AgBr, AgCl, it shows Frankel defect. AgBr is the compound which shows Frankel as well as Schottky defect. AgBr, it shows the Frankel as well as Schottky defect. अब देखिए non-stoichiometric defect shown by non-ionic compound. It is of two types, vacancy and interstitial defect. Vacancy, as you know, hole is created When hole is created, what will happen? The volume will decrease and density will increase. Whereas in interstitial site, the ion has the atom has not left the crystal site. It is there only, but it has occupied the interstitial site. Here also the volume is also increased, therefore density is also there. So you saw in Frankel and Schottky defect, in Schottky the size will decrease due to loss of ions, but in Frankel defect the density remains the same since the ion does not leave the crystal site. Both are electrically neutral. Both are electrically conductive. It can conduct electricity also. So now the next two topic will be in the next video, that is non-stoichiometric defect and impurity defect.